All right, let's just jump right into this explainer. Today, we are going to fix literally one of the most annoying parts of your daily coding workflow. If you're using an AI coding agent, and let's be real, most of us are at this point, you already know how incredible they are for writing boilerplate, squashing bugs, and just generally building features faster. But today, we're looking at something that takes it to the next level. It's an open source project called Agent Memory, and it is designed to give your AI a permanent brain. We're going to break down exactly how this system stops you from constantly repeating yourself and why it's a total game changer for your productivity. Seriously, be honest with me for a second. How tired are you of re-explaining your code base to your AI every single session? We all know that exact frustrating feeling. You sit down, you're caffeinated, you're eager to code, and you end up wasting the first 10 minutes just re-explaining your entire stack. You're typing out the specific libraries you use, you end up rediscovering the exact same bugs you just fixed yesterday, and you're forced to reteach the AI your basic architectural preferences all over again. Especially if you're a newer developer, this constant resetting completely shatters your flow state. Just when you're holding a really complex problem in your head, you have to stop, go dig up file paths, and type out the basic context. Every time you close that terminal, your AI basically gets complete amnesia. It's like Groundhog Day, and it really slows down your momentum. To understand how we actually fix this amnesia, we need to look at how memory is handled right now. Currently, your AI's built-in memory, stuff like a CLAD.md file or cursor notepads, functions essentially like a digital sticky note. It's got a super strict 200-line cap, it goes stale incredibly quickly as your project evolves, and worst of all, it forces you to manually edit and prune it. It just becomes another chore. But agent memory takes a completely different approach. It acts as a fully searchable, unlimited database. Instead of a tiny manual sticky note, it's this automated backend that silently captures what your agent does, compresses it, and organizes it for you without you lifting a single finger. It's a massive paradigm shift from manual note-taking to a fully automatic memory engine. The core promise here is beautifully simple, but absolutely massive for your daily work. Your coding agent remembers everything. No more re-explaining. Just imagine opening your laptop for session 2, and your AI already knows you use the Joe's middleware for edge compatibility. It already knows your tests require specific token validation. And it knows all of this without you typing a single word of context. There's literally no copy-pasting required. The agent just knows. The speed at which you can jump straight into the actual complex problem solving with a system like this is off the charts, because all that foundational context is already established.
Now let's talk about something we all care about, your wallet. Persistent memory doesn't just save you a ton of time, it actively crushes your API token costs. Think about it. If you try to paste your full context into the prompt every single session, you'd blow past your window limit so fast, we're talking potentially over 19 million tokens a year. Traditional LLM summarized memory methods can run you around $500 a year in API usage just to maintain context. But because agent memory compresses your history so efficiently, it drops that cost down to roughly $10 a year. And it gets even better. If you configure it to use local embeddings, which are totally free and run offline, your token cost for memory drops to exactly $0. It is an incredibly efficient way to manage your resources.
Now, if you're a new developer looking at this, you might be thinking, oh man, do I have to learn a whole new IDE to use this? Absolutely not. That's a crucial point here. You do not have to change your workflow at all. Agent memory works seamlessly with the tools you already love, whether you're using Claude Code, Cursor, Gemini CLI, Codex, Windsurf, RuCode, or honestly virtually any client that supports the Model Context Protocol, or MCP. If you haven't heard of MCP, it's essentially a universal standard that lets AI tools talk to each other seamlessly. You're covered. It just plugs right into your existing config file and runs as an invisible background server. You keep your favorite environment, it just gets significantly smarter overnight. Okay, so how does this actually work under the hood? It is a beautifully simple 3-step mechanism. First up, it uses 12 different lifecycle hooks to automatically capture data. So for instance, the split second you open a new Python file, or the moment the AI hits a specific runtime error, a hook quietly takes a note of it. Second, it silently compresses and stores that data in the background without ever interrupting your work. And third, it injects the exact right context the moment you start your next session. There is zero manual effort required from you. You don't have to hit a save button, you just code like normal, and the system learns your patterns as you go. And what happens to all that captured data is fascinating. It gets processed through a 4-tier memory consolidation process that is actually heavily inspired by the human brain. First, you have working memory. This is for raw, short-term observations, right? The immediate tasks right in front of you. Then, episodic memory creates summaries of what happened in a session, kind of capturing the overall storyline of your work. Next is semantic memory, which extracts the cold, hard facts, the what I know stuff, like your architectural rules. And finally, procedural memory learns your specific workflows, the how to do it. Basically, your AI sleeps on it, running background tasks to organize and remember complex concepts, exactly like our own brains do after a long day of learning.
But here's the kicker. A healthy brain isn't just about hoarding facts. It's also about forgetting the useless stuff so you can actually think clearly. Memories in this system naturally decay over time. However, if a memory is accessed frequently, say a core architectural rule you rely on every single day, it gets strengthened. On the flip side, if it's some stale bug fix from 3 months ago that doesn't even apply to the codebase anymore, it auto-evicts. This is huge because it prevents the AI from stubbornly clinging to old, buggy logic, which is a massive headache we've all dealt with. The system actively detects and resolves contradictions automatically. It's entirely self-cleaning, making sure your AI's context window stays lean, incredibly fast, and always relevant.
So when your AI actually needs to recall one of these memories, it uses what's called a triple stream search to find it fast. It doesn't just rely on one basic method. It combines BM25, which is basically your exact keyword matching, with vector similarity. Vector similarity is awesome because it understands the actual meaning and context of your code, even if you use totally different words in your prompt. And on top of that, it uses a knowledge graph to connect the dots between related entities. By fusing these three methods together, using a technique called reciprocal rank fusion, it finds exactly what you need. It's like magically fetching an old N+1 database query fix completely automatically, even if your current prompt didn't use those exact terms.
And let me tell you, the results of that search architecture are no joke. On the long mem eval S real-world benchmark, this system scores a 95.2% accuracy rating for retrieval recall at 5. To put that in perspective, a basic keyword-only fallback system sits way down at 86.2%. That 9-point jump, that is a massive technical achievement. What it actually means for you is that when your AI reaches into its permanent brain for a crucial fact, it is overwhelmingly likely to pull out the exact right piece of code or architecture rule on the very first try, rather than making you stop and hunt for it.
Now, I know what the security-conscious developers out there are probably thinking, wait, is my AI going to permanently save all my API keys and production secrets into some database? The answer is a definitive, absolute no. Agent memory is built from the ground up with a complete privacy-first approach. All of your sensitive secrets, tokens, and literally anything you wrap in specific private tags are totally scrubbed and stripped out before anything is ever committed to storage. Your secure data stays entirely secure and entirely local to your machine. It is a completely safe environment to work in.
You'd think an engine this smart and powerful would require a massive, clunky tech stack to run locally, right? Well, actually, agent memory is beautifully lightweight. Because it runs on these streamlined primitives called the II engine, there is absolutely no Postgres database to install, no Redis cache to spin up, and no ExpressJS servers to maintain. For a new developer, this is a huge win because it means zero complex local environment setup. It replaces all those heavy traditional tech stacks with just one simple background process that seamlessly handles your streams, your triggers, and your state, all at once.
And if you're anything like me and you love peeking under the hood to see exactly what your tools are doing, you're going to love this. The system comes with a built-in real-time viewer. You just pop open localhost 3113 in your browser while you code. Imagine having this running on your second monitor. You can actually scrub through your session timelines, watch memories get written and consolidated, and literally see the knowledge graphs form and connect in real time as you work. It gives you this incredible observability into exactly what your AI is learning and how it is actively processing your project. It's honestly just really cool to watch.
So it all comes down to one ultimate question. What will you build when your AI finally remembers? We've seen how agent memory completely eliminates that daily grind of re-explaining your stack. We've seen how it drastically cuts your token costs and how it acts as a self-cleaning, highly accurate permanent brain for your coding agent. All you literally have to do is drop it into your existing MCP config file, fire up your next coding session, and you get to experience a truly persistent, brainy AI assistant that actually grows alongside your project. It is a real game changer. Thanks so much for joining me on this explainer, and hey, happy coding!